Alright, for this lesson we're taking a look at what's known as the laws of exponents for multiplication and division. Well, these laws can be summed up pretty easily when you have a case where you are multiplying and you have like bases. What you end up doing is simply adding the exponents like so. If you have a case where you have like bases and you are dividing, what you end up doing is simply subtracting the exponents. If you have a situation where you have a base to a power and a power that is being raised to, that just ends up being the base, and then you multiply the two exponents. So these are the three basic laws of exponents. When you multiply like bases, you add the exponents together. When you are dividing the exponents or dividing the bases and you have like bases, you're going to subtract the exponents. And when you have a case here where you have a base raised to a power and that has an exponent outside of it as well, you just come over here and you're going to multiply your exponential values. So let's take a look at a few examples and see what that would look like. Well, if I had, let's say, x to the 4th and I was multiplying that times x to the 6th, well, that goes back over to what we'd had over here. I'm multiplying, I have a like base, so I'm going to do is take x to the 4th plus 6, which gives me x to the 10th. Okay. Likewise, if I had 3 squared times 3 to the 5th, that gives me 3 to the 2 plus 5, which gives me 3 to the 7th. Now if we switch gears a little bit here and take a look at some of the division, let's say I have x to the 9th, and I'm dividing that by x to the 3rd. Well, that means what I'm going to have is x to the 9th minus 3, which gives me x to the 6th. If we had, let's say, 6 to the 8th over 6 squared, well, I am going to simply rewrite this as 6 to the 8 minus 2, which gives me 6 to the 6th. Now if we were to take a look at one of those other examples, and let's move this back up here so we can see it. Take a look at one of these other ones, right, just like this. If I had x to the 4th, let's say I was going to raise that to the 5th power, that'd be the same thing as saying that it's x to the 4th times 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 x to the 4th. And because it's 1, 2, 3, 4, 5 of them, as this exponent implies, that's why we take 4 times the 5, because then you also have to expand this out. So each one of these x to the 4ths is actually x times x times x times x. And so you have to repeat that for all 5 of these. So that's how we end up getting this when we solve. We rewrite it as, just like this up here, x to the 4th times 5, which gives us x to the 20th. Now if we replace the x with a numerical value, let's say we have 5 squared, and we're going to cube that. Again, it's the same idea as 5 squared times 5 squared times 5 squared. And that in turn would be 5 times 5, 5 times 5, 5 times 5. So you can see that this grows exponentially pretty quickly. So that's what allows us to just say we're going to multiply those two exponents. So we get 5 2 times 3, 5 to the 6th, which we can then see 2, 4, 6. So that's a little bit about the laws of exponents. Remember, when we are multiplying like bases, we add the exponents. When we are dividing like bases, we subtract the exponents. And when we have a base raised to a power, and we're going to take that to an exponential value as well, we just multiply the exponents. So that, in a nutshell, laws of exponents.